Well, hello, members of 7th grade Blue. Happy Teacher Appreciation Day. Woo! I'm going to flip the script, as you may have heard. You know what? I appreciate your appreciation. Go ahead, a round of applause. Thank you very much. But I'm going to flip the script on this because really my vocation leads me to appreciate you. I appreciate you more than you could ever appreciate me. And as a small reward and a token of it being National Teacher Appreciation Day, I'm going to give you half homework. So this is L104, so your homework will be HW104 evens. There is one other homework you're going to have to do. Let's dive right in. This is kind of an involved lesson. L104, metric system, volume, capacity, and mass. So here's something that we don't really grow up with, and that's because we don't live in the metric system. But I would imagine every school child that lives in every other country except for ours basically gets to know this fact. And that fact is that 1 cubic centimeter contains 1 milliliter of water weighing 1 gram. This is water under standard conditions. If we were going to kind of parse that out, we might make this statement. So if we think about volume would be 1 centimeter cubed or 1 cubic centimeter. And that volume translates to something that we call capacity. And we know our measurements for capacity in the metric system are liters or milliliters and centiliters. So 1 centimeter cubed is equal to precisely 1 milliliter. And this is water, of course. And then the last is we'd take that and we'd think about, well, what about mass? How much does the thing weigh? And as it says there, it weighs 1 gram. And again, I know this is not basic information for you, but it will behoove you to learn this fact. Maybe you'll go live in another country besides America and people will expect you to know this. Or maybe you will be asked homework questions about it at the very least. So let's imagine this visually. So let's say I drew a cube that has 1 centimeter as a side length. What this is basically saying is if I filled this thing up with water, it would take 1 milliliter of water for me to fill that up. Also, if I handed it to you, you would feel the weight of precisely 1 gram, which wouldn't be heavy at all. All right, let's press on because we can take this same fact and get out here where we think about still volume, capacity, and mass. And we can kind of take that fact and go, okay, well, if that's true, wouldn't it be true that 1,000 centimeters cubed, so instead of just 1 centimeter cubed, would equal 1 liter? Because before it equaled 1 milliliter, we know a liter is 1,000 times that. And then we could move that out to mass and think about, well, what's 1,000 grams? It's a kilogram. And this, again, a basic fact that most people in the world likely know because they grew up in the metric system. Again, this is about water under standard conditions. Let's dive right into a problem. So Ray has an aquarium that is 50 centimeters long and 20 centimeters wide. It is filled with water to a depth of 40 centimeters. So I would suggest to draw this out. So if I was to draw that out, I draw a nice kind of like rectangular prism. And I'm going to label up, so 50 centimeters long. And then it says it's 20 centimeters wide, and it says it's filled to a depth of 40 centimeters. And again, this is an aquarium. Let's draw some fish, maybe some water. Boom, boom, boom. Okay, now here are our questions. How many liters of water can fill this? Well, if you think about this is a question about liters. Now, in order for me to determine the liters, I do need to go to volume first. We know volume is V equals LWH. And so if I work that through, that's going to be 50 centimeters times 20 centimeters times 40 centimeters. I'll do the 50-20 first. So 50 times 20 is clearly 1,000 centimeters squared. And then I'll multiply that by the 40 centimeters. And that would be 40,000 centimeters cubed. Now, that didn't answer my question, but I can use this fact that 40,000 centimeters cubed and the fact above that 1,000 centimeters is equal to 1 liter, and then go, well, if 40,000 centimeters, wouldn't that make 40 liters? And yes, it would. You could box that up. Now, the second question is, well, what's the mass of that water? So once again, we go up to our idea about mass, that 1 kilogram is equal to 1 liter. And if I have something that's 40 liters of water, then that would have to mean, 40 kilograms, wouldn't it? And again, these basic facts that the rest of the world knows and we don't necessarily operate under will be very helpful when you do these problems. Let's do another. Malia wants to find the volume of a vase, but it's an irregular shaped vase. She fills a 1 liter container with water and uses all but 280 milliliters to fill the vase. So I've drawn my pretty vase with the pretty flowers. And then what's basically happening here is there's a 1 liter container. This precisely holds 1 liter of water. And she fills it up, but there's some water left. There's 280 milliliters left. So if I think about that, I know that 1 liter is based upon the facts that we looked at before. 1 liter is equal to 1,000 milliliters, right? So if we think about, we should just know that as a basic fact. So if I subtract off that 200 milliliters, I would get 720 milliliters. That's what is filling the vase. Now, a question of volume is what they're asking. In fact, we have 2 questions for this. The first is, what is the volume of the vase? And the second is, if the mass of the empty vase is 640 grams, was its mass filled with water? Let's deal with volume first. So again, we do know this. 720 milliliters would equal what? Well, what's our fact? Now, we saw before that 1 milliliter of water is equal to 1 centimeter cubed, and that's a question of volume. So if I have 720 milliliters, wouldn't that be 720 centimeters cubed? It sure would. And that's a question of volume, right? That's my volume. So that I could box up. Now, it goes on. It says, if the mass of the empty vase is 640 grams, what is its mass filled with water? So once again, I'd have to take this fact. I know that 1 centimeter cubed is equal to 1 gram. That's mass. And so if I have 720 centimeters cubed in volume, that will be clearly 720 grams. Now, don't box that up, because remember, what we're doing is we're going to be adding it to the vase. The vase's weight of 640 grams, or its mass. So if I add that, then I would get 1,360 grams, which will be if you carry the vase to someone with it filled with water. And you might go, is that heavy? It's not too heavy. I'm sure you could handle it. Yeah? All right. Important stuff. We've got more. Let's write this all down. You can go ahead and pause me if I start to move too quickly. It says, on a fishing boat, bait is kept in a cubic tank measuring 1 meter on each edge. I'll draw that up. So that would just look like this, right? 1 meter. So what's the tank's volume? Well, again, we know that volume for a cube is V equals S cubed. Therefore, it's 1 meter cubed. Now, if we look back, we don't have any things that help us with that. So 1 meter cubed. Oh, I've got this 1,000 centimeters cubed. Let's go there. Let's put it into centimeters cubed. Now remember, this is why we do unit multipliers. So if I take 1 meter cubed, I'd have to multiply that by 3 unit multipliers to give me the opportunity to cancel out those meters. So what would that be on top? 100 centimeters, 100 centimeters, 100 centimeters. And then obviously boom, 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 boom. And then, so what do I got? Let's just count the zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, commas. So that's 1,000 centimeters cubed. And that's a question of volume, right? Or I'm sorry, not 1,000, 1,000,000 centimeters cubed. And that I could box up. Now it goes on. It says, well, what's the capacity of the tank in liters? Well, we do have this fact that 1,000 centimeters cubed is equal to 1 liter. So if I've got 1,000,000 centimeters cubed, so what is that? So 1, 2, 3, there's my 1,000. That would represent what? Well, it would be 1,000 liters would answer the question of capacity. And I could box that up. Now let's move on. It says, what's the approximate mass? So now we're moving to weight. And that's where we're going to think about grams. And listen what they want. They want it in kilograms and they want it in pounds. And they give us a nice little conversion. So let's do the kilograms first. So again, we have a basic fact about this. And it's this basic fact right here. 1 liter equals 1 kilogram. So if that's the case, 1 liter is equal to 1 kilogram. And I've got something that's 1,000 liters. Well, yeah, what do you think? Well, of course, it would be 1,000 kilograms. And I could box that up. However, there's more. They want me to use this conversion rate. That's actually not equals, it's an approximate. I'm going to change it later. Can you put an approximate? So 1 kilogram is approximately equal to 2.2 pounds. Let's use a unit multiplier here. So I have 1,000 kilograms. I'm going to say that that's approximately equal to, and I'll say 1 kilograms down there, 2.2 pounds. And then that's approximately equal to, so slash on my kilograms, which I didn't do, but I'm going to move that decimal place 3 times, 1, 2, 3, and I should end up with approximately 2,200 pounds. All right. Now, the next question is connected to this one, and you don't have to write the next question. You will have to do something with it. So it says right here, no need to write. So no need to write. I just want you to think it out. To increase the water supply, they will replace the old water tank. The new tank has dimensions of 30% or greater, of 30% greater. If the old cylindrical tank is 10 meters high and 20 meters in diameter, new tank will hold how many liters? Ooh, big question. And they give us choices. So you're not going to write this. I just want you to think about it. All you're going to do is you're going to answer. And you have choices. Do you think it's this in yellow? Do you think it's the purple? Or do you think it's the blue? And once you've figured it out, I do want you to figure it out. Like, let's make this a goal for you, a goal on National Teacher. Hey, that's how you could appreciate me. That's your National Teacher Appreciation Day coming back at me. You're going to answer, but I need you to answer now on Google Classroom or whenever you figure it out. Obviously, use paper and pencil. Take your best shot. You know, obviously it's connected. You know, it's not connected to this at all. It's not connected to the problem before. This is its own thing. I just want you to think. I know you can get the right answer. Here's what you're not going to do. You're not going to wait for someone else to respond on Google Classroom and then just put whatever they put down. That's not what a 7 Blue student will do. What will a 7 Blue student do for me? Well, again, you have that to answer on Google Classroom. Just post it in the reply there. And then you have HW104. Remember, evens only. Hope you're well. You can reach out to me anytime. Bye.